molar heat, we have heat that is in the equation. And I would love to go over one of these with you, but I'm going to choose to go over this one, the creating the equation, because this one goes over all the pieces with a special little twist. So again, I'm just going to go over this with you briefly, checking my time. I should be good. So first off, it says that methane undergoes a combustion when burned with oxygen. How much is released if this much methane is combusted? Okay, so this here is telling us that there's a reaction and we might need to do something about that because we are going to go from methane to heat. We are going from one thing to another. We need a balanced chemical equation. Fortunately, we've done the methane equation a couple times. Okay, we have CH4. It's burned in excess oxygen. And it's a combustion, so it releases CO2 plus H2O. We balance it real quick just to get that out of the way. We're going to need 2 waters and we're going to need 2 oxygens, and then that's going to be balanced. But the new thing is this. The new thing is this heat. Now, because the heat is negative, that means that this is exothermic. It is released. So we put a plus, because we don't put minuses in our equations, 890.3 kilojoules. Again, because it is negative, it goes at the end of the equation, and we still put a plus there. This tells us it's at the end. Okay, so I put that in there. At this point, I can now go back to my question. Okay, so I've got my start here, my 44.2 grams. And this is methane, CH4. The first thing I'm going to want to do is I'm going to want to get this to mole. So I'm going to take my grams of methane. I'm going to change that to moles of methane. This is a normal mole conversion, so 1 mole equals the atomic mass in grams. Weighs 16.05, 12.01 from the oxygen, 4.04 from the 4 hydrogens, 16.05 total. And then we do basically what is a stoich step. We're going to bring our moles of CH4 down, and we're going to change that right to kilojoules. Just like we did before, we've got the moles right here, and we're going to get our kilojoules from right there. So just like with normal stoich, we're grabbing it from the equation, we do that same thing with molar heat. So there is 800, sorry, I didn't mean to press that button, 890.3 kilojoules for every 1 mole, because the equation told me so. So I take 44.2 divided by 16.05, times it by 890.3. I get my answer, and I've got 4 sig digs, 3 sig digs. I go with the 3. I go with whichever one is least sig diggy. And so that's 2, 4, 5 placeholder kilojoules. That is how much heat is released from that small sample of methane being burned.